Alright guys, welcome to notes number 2. The title of these notes is Unit Conversion and Scientific Notation. We're going to be covering both of these topics today in these notes, and we're going to start with unit conversions first. In the last class, we did the measurement lab where you were taking lots of different measurements of lots of different things, volume, length, all kinds of stuff. So we were mainly using the SI unit, or the standard international unit, or the metric system in all of our measurements that you guys were taking. But sometimes we need to convert from one unit to another, okay, whether it's from meters to inches or, for example, meters to kilometers, okay, or maybe grams to kilograms or milligrams back to grams. Okay, we're going to have to convert between different units. And so we're going to cover the first question, which is how do I convert from one unit of measure to another in this slide. Okay, so to convert between one unit to another, we're going to use what's called a bridge. Okay, and in bridges, the units drive the conversion. All right, so the key concept here is going to be canceling units. So I'm going to draw kind of a bridge and kind of show you how the setup works, and then we're going to go through the 5 different steps and then a practice problem to help you guys know how to set up and use these. They're called dimensional analysis bridges. I just call them bridges for short. Okay, so how to use these bridges to convert from one unit to another. So the key concept in using bridges for unit conversion is, again, canceling units. So I have this little bridge here, and it's like a suspension type bridge, like the Golden Gate Bridge. If you've ever been there, seen pictures, we've got a little water underneath our bridge. This is kind of like the visual that we're going to use when using bridges. Now let me show you how we're going to use this visual in setting up conversion bridges for science. Our bridge here for science kind of has the same setup, except without the little, the drawbridge kind of strings. And on the left side of our bridge, we're going to have our original unit. So there we have our original unit on the upper left-hand side. And over on the right-hand side of our bridge, we're going to have the new unit, okay, the unit that we want to convert to. So the original unit is what you're given in a problem or a situation, a scenario, and the new unit is what you want to convert to. Now to get rid of the original unit, we need to put that unit down on the bottom in order to cancel it. Okay, so we have our original unit on the top left-hand side, and in order to cancel that unit, we have to put it on the bottom right-hand side. Just like you see here. We're going to have the original unit at the top left and the down on the bottom right, and our new unit is going to be on the top right-hand side of our bridge. So it's kind of like we're walking across the bridge from left to right, on top of the bridge, just like you would do if you crossed over a bridge. You go from your original unit, walking all the way over to your new unit. Okay, so as we do our math on this bridge, what we're going to see is that, again, the top and the bottom original units will cancel, leaving just the new unit in the end. So we've successfully converted from one unit to the next, as you see here. Okay, so now we're going to go over the 5 different steps of setting up these bridges in order to cancel the original unit and get to our new converted unit. So here we have, again, our skeleton of our bridge that we're going to use to convert things. And again, just like I had said earlier, we're going to set up the top left side of the bridge with our original unit, with what you are given. You're always, always, always going to start on that top left-hand side with whatever unit you're given. Okay, so there's our original unit on the top left-hand side. Now the second step is to set up the top right-hand side of our bridge. That's where we want to go. with the new unit, okay, what you need to convert to. So if the problem asks you to convert from, 3 inches to centimeters, okay, or what if it said, how many centimeters are in 3 inches? Well, you're given the 3 inches. That's your original unit is inches. And so that goes on the top left-hand side. The top right-hand side is for centimeters because that's what it's asking you to convert to is the centimeters. So we have the new unit on the top right-hand side. Now the third step is to set up the bottom right-hand side with that original unit. Okay, so if we're talking about 3 inches, okay, the inches goes on the top left-hand side and then again on the bottom right-hand side because we need to cancel those units in order to get just centimeters left over. So we see that there. Now we're ready to actually put numbers into our bridges. If you've noticed, all the time I've said before, we are just working with units because, again, the units drive everything. If you can put your units in the correct spot, the numbers just match up with the units. So we've just been talking about units because the units are the key in order to convert from one unit to another. Okay, so now way down here at step number 4, we're actually going to be putting in the numbers. So we're going to put in the correct numbers for the units. So for the original unit, up on the top left-hand corner, you're going to put the number that you're given. Okay, so if we're working with that example, how many centimeters are in 3 inches? We will have 3 inches up on the top left-hand side. And then the right-hand side is for the appropriate conversion factor. Okay, so for example, how many centimeters are in 1 inch? Or when we get to using these bridges in the future with stoichiometry, we're going to be figuring out, how many grams are in 1 mole, or what is the mole ratio. Okay, so that all happens on the right-hand side of the bridge, and I'll go into more detail and show you guys in the example coming up. But for now, step number 4, put in the correct numbers. Our last step, step number 5, is do the math. Now that we've got numbers in our bridges, now we can actually do the math by multiplying the numbers on the top of the bridge together and then dividing it by the bottom number. So it's kind of like a big, huge fraction. You multiply the numbers on the top to get the top of the fraction, and then you divide, by that bottom number on the bottom to get your actual answer. Okay, so now it's actually time to show you what these steps look like when we're actually doing a problem ourselves. So the next question is going to be an application question for these 5 steps. All right, our second question then is, again, an application question that says, how do I convert 132.6 centimeters to inches? Okay, so here we're starting with the metric system in centimeters, 132.6 centimeters. But, if we're talking to somebody who, only lives here in America and has never heard of the metric system, then we're going to have to convert those to inches so that we can speak the same language. So here's how we're going to do it. First, again, we set up our bridge. Okay. We've got, the top left side is for the original unit, and the original unit we can see is centimeters. So we're going to put centimeters on the top left. Okay, and so that's step number 1, right, is to put our original unit on the top left of the bridge. Okay, now the second step is to put our new unit on the top right-hand part of the bridge. So what we need to convert to, okay, is inches. That's what it's asking in our question. So on the top right, we'll put inches because that's what we need to convert to. All right. Now the third is to set up the bottom right side of the bridge with, again, the original unit because we need to cancel them. All right. So the bottom of our bridge, because we have centimeters on the top left hand side, we need centimeters also on the bottom right hand side. Okay, so what's going to happen is when we do our math, okay, the centimeter on top is going to cancel with the centimeters on the bottom, and all we're going to be left with is inches, which is exactly which we want, is just inches, according to our question. Okay, so let's see. So we've got our first step is centimeters, the original unit on the top left-hand side. Our second step is our new unit on the top right-hand side. And our third step is that original unit down on that bottom side. Okay. Now we come to the fourth step, actually plugging in numbers. Okay, and these numbers are going to come from two different spots. Okay, again, on the left side of our bridge, this is our original unit, so this is what we originally start with. So the number that we originally start with is 132.6. That's what we're given in our question. So that's the number that we put on the top left-hand side, 132.6. Okay, so that's where we get that. Now, the right-hand side, a little bit more tricky. It's not as, given in plain sight as, the original unit or the original measurement. This on the right-hand side is what we call a conversion factor. Okay, so they have to be equivalent. The top and the bottom, has to be equivalent according to our units. So basically what it's asking is how many inches are in a centimeter, or how many centimeters are in an inch. Okay, so this is again what we call the conversion factor. Most conversion factors here in chemistry will be given to you. Okay, so for example, this one is 1 inch equals 2.54 centimeters. Okay, that's just a given. Anytime you're measuring an inch, it's going to be equal to 2.54 centimeters. So we put those numbers there in order to make inches and centimeters equivalent to each other. Okay, and so there we had step number 4. We put our original what number that we're given and our conversion numbers here, okay, on this side. For step number 4. And now step number 5 is, you guessed it, do the math. Okay, so here we're going to multiply our numbers on top. 132.6 times 1, okay, equals 132.6. Okay, and on the bottom we just have the number 2.54. So again, it's like I said, it's like a big fraction, 132.6 over or divided by 2.54. And when we do that math in our calculator, we'll get 52.2. Now, again, our centimeters are going to cancel, so what we're left with is our new unit, inches. Remember, like I told you last time, we have to have a unit with our number. The measurement means nothing without the unit. Okay, and last but not least, just a little reminder there that the conversion factor will be given to you in the problem, or you may need to look it up, but most likely it'll be given to you either on a separate reference sheet or within the problem itself. Okay, so that's how we convert from one unit to another. Now, we go through this big bridge process because when it comes time to stoichiometry and more complex chemistry, which we will start the first of the next semester, we're going to be using bridges and connecting different bridges together, and it's just much easier to do the stoichiometry if you can get the bridge, the simple bridges down right now. Okay, so that's why we're going through all of this, bridge setup and everything. So when you're doing your guided practice problems tomorrow, you're going to have to do it this bridge way. Even if you think you know a simpler way to do it, okay, please practice this bridge way because it's going to make your stoichiometry life so much easier. All right, we're going to get to the second part of these notes, which is on scientific notation. So let's take a look at that. Okay, so you should know what scientific notation is from previous math classes, probably like upper elementary and middle school. But basically, scientific notation is a way of representing really, really big or really, really small numbers. Okay, so, if you have a number that's millions and trillions, in the place value, we can kind of simplify that number by expressing it in scientific notation in order to kind of tame all of those zeros or placeholder digits. Likewise, if we have a really, really small number like 0.000000076, okay, we can also use scientific notation to express that in a much easier way. So scientific notation expresses these numbers as two different factors. Okay, the first factor is a number between 1 and 10. So a number between 1 and 10 is always going to be the front number, and I'll show you guys in just a sec. And then the second factor is an exponent. Okay, so again, we have a number between 1 and 10 and an exponent. So for example, an example here, all right, would be the number 2.8 times 10 to the negative 8. Okay, so that is a example of a number that is written in scientific notation. Now, the exponent is going to tell you how many times the first number is multiplied by 10. Okay, so if the exponent is negative, it's going to be a really, really, really small number. And if the exponent is positive, that means it's going to be a really, really big number. Okay, so let's get those concepts down in our notes. All right, so again, the key concept, the number one key concept here is that when you're looking at a number written in scientific notation, if the number is bigger than 1, okay, or bigger than 10, if it's going to have a positive exponent. Okay, so really, really, really big numbers have positive exponents. Okay, and the ones with that are smaller than 10, so those are all your decimal numbers like 0.023 or 0.0000567. Okay, those guys will have negative exponents. All right, so that is something, it's a key concept there. So you can tell if a number is really big or really small by looking at the exponent. If the exponent is positive, it's a really big number. If the exponent is negative, it's a really small number. Okay, so our last question is basically just going to go over converting numbers into scientific notation, okay, or rewriting them into scientific notation. So let's take a look at that. Okay, so first we're going to take a look at the number 0.00036. Okay, so this is, if we look at it, it's a decimal number. So from our key concept before, we'll know that this, when we write this number in scientific notation, we're going to have a negative exponent because this number is smaller than 1. It's a decimal number. Okay, so to convert this number into scientific notation, what we do now is we just play with the decimal points. Okay, so we have to put this decimal point in a spot. We have to move it to a spot where, again, we get a number between 1 and 10. Okay, so we're going to move this decimal point over 1, 2, 3, 4 spots. Okay, so we're going to move it over 4 spots so we can make, so if we convert this, we're going to make the number 3.6. Okay, and that, again, is a number between 1 and 10. And because we move that decimal over 4 spots, our exponent is going to be 4. Okay, but we know that because it's smaller than 1, our exponent has to be negative. So it's not only going to be 4, it's going to be negative 4. So to put 0.00036 into scientific notation, okay, it would be 3.6 times 10 to the negative 4. Okay, same number, just a different way to write it. So let's get kind of that method down in our notes. So here we have in our notes just kind of the method reminder to move that decimal over. In this case, we moved over 4 times. Some cases we might only move it once. In other cases, we might have to move it 20 times. But we move that decimal over as many times as we need in order to get a number between 1 and 10. And then we write that number, okay, how many times we move the decimal, as our exponent. And then if it's a number bigger than 1, we leave it positive exponent. But if it's a decimal number that's smaller than 1, then we will put that negative in front of that exponent. Okay, so let's try just one more example of converting a number into scientific notation. All right, so for this last example, we have the number 365,000. We're going to put it into scientific notation. So again, what the idea is that we need to move the decimal over as many times as we can, either left or right, in order to get a number between 1 and 10. So in this number, the decimal is actually hidden. If it's not written, we always assume it's at the end. Okay, so we can say that that's our decimal point. And we're going to move it over 1, 2, 3, 4, 5 spots, okay, to the left to make 3.65, okay. And again, our exponent is however many times we moved that decimal over. So in this case, we moved it 5 times over, so our exponent is 5. All right, and if we take a look at our number, it's greater than 1, it's bigger than 1, so we keep our exponent as positive because it's going to tell us it's a really big number. Okay, so let's write that last reminder down in our notes. Okay, so there we have it. The exponent again in this number stays positive because the number the number 365,000 is a number that is greater than 1. It's a really big number. Okay, so that's all the notes for these notes number 2, unit conversions and scientific notation. But please don't forget, you also have to go through notes number 3 before next class as well. So there's 2 note assignments, these notes and the next notes. So make sure you do both of them before next class. All right, we'll see you then.